Lou, welcome back. Great to have you back on another episode of Dredging Deep. But today, you want to rename our episode to Scratching the Surface. Tell me why that is.
Yeah, John. And thanks for having me back for another session. And yeah, I'd given it some thought and um, dredging deep, but as we see it, we're really just scratching the surface in where we're at, and we've started to emphasize surface, and I'll build on that for you. And the bottom line is it's the surface that we're interested in. What's the
Right.
bottom look like, right? And the more we go into potential customer sites, we always start with, okay, to the operator, to the plant manager, the owner, what was your intention? Where were you trying to dig to? And they'll tell us, and we'll go in and we'll measure the bottom. We'll get a survey from somebody. We'll measure the bottom, and we'll create that surface.
Mm-hmm.
And where they got to is never. I mean, we're batting 100. We've yet to have a customer that got it right as to where they think they are without using any kind of a guidance system.
And these are from mines, right? Like
These are ag match.
I know that you kind of went out and went and looked at several. You picked I know I sent you a few of ours. Went to 4, 5, 6 of them, and out of all of them, not a single one.
Yeah, and we've been doing it beyond the ones you sent us. So
Yeah.
And it's always a surprise.
Mm-hmm.
And really, again, what we really want to know is what does the bottom look like? What is that 3D surface? And when we go in, we find, there'll be almost like shelves, and to us, that's obvious. Their reference is water surface elevation, right?
Right.
And that fluctuates, and
Oh, I
if
see.
it fluctuates a lot, then this shelf, right,
Right.
happens because the dredge was higher or lower by when they came into this next phase
Right.
or whatever. And then we'll also see, it's an arc-shaped crest that they've missed,
Right.
and that's when they move forward with the on the
Too
anchors
far. Yeah.
too far, and they missed. There's a 5-10 foot swath
Mhm.
back there, and we've gone in and looked at the volumes of what they left behind as to what they wanted to get, and I asked our guys to compute those volumes on a per acre basis, and the material that was left behind when we addressed that with the customer, we just got that deer in the headlight look, kind of like those lights right there,
Yeah.
and they were totally amazed, and I'm sure somebody heads got lopped off, but
Yeah.
the numbers when I first saw them, the quantities per acre
Yeah.
were unbelievable, and I sent it to another one of our techs to look. Hey, check these numbers. So 3 of us went through
Yeah.
the numbers. I said, this can't be right, but it was right.
And that's kind of because most ag mines out there, if they have older equipment, they may really, quite honestly, have a dial on the ladder that points to how deep the ladder is, and that can fluctuate based on the water level in the actual depth is based on the water line, not on the actual depth based on some the sea level or whatever,
Right.
right?
And
So that throws everything off.
that's fluctuating, and that's one of the surfaces that we need to understand and get control of, because everything's relative to that for a
Right.
dredge operator, right? And as it turns out, the way things have evolved, our GPS, our GNSS systems, really, now we use a satellite correction.
Right.
It's a subscription service from Trimble. It's called Trimble RTX.
Mhm.
But what that does is it brings us a consistent surface that dredge is always going to be on now. And relative to that surface created by the GNSS,
Right.
if the water goes up or down,
Doesn't matter.
It accounts for that.
Right.
2 feet up, it adds 2 feet.
Mhm.
4 feet down, it takes away 4 feet.
Right.
So we've taken that issue away. And so now we can get consistent surfaces at the bottom. What does the bottom surface look like? And the surface is all critical because that's where you're computing quantities.
Right.
That's where you're measuring your productivity and checking against the model of where your materials
Right.
and such are. The good materials. So now we're looking at surface in a lot of ways. That the surface is all important to understanding what's going on the bottom. And we can get that surface with our guidance system, right?
Mhm.
So we start with a 3D surface, and as cutter head moves through, we remove that from the model.
Mhm.
And that's a pretty good animated rendition of what's going on. And if the operator is paying attention and using the system as he should, there's not going to be surprises, right? You're not going to find that missed crest in the middle when they moved forward, or the bench where
Yeah.
it went up or down. That's no longer going to be there. And he can use that. The issue with the cutter head passes can become if there's cave offs or things like that,
Mhm.
because the cutter head doesn't know that.
Right.
So
That's likely to be pretty minimal compared to the overall time that you're out there.
It typically is, and but if it's of issue and if it's a time critical kind of thing, then we supplement it with a sonar.
Right.
And and even sonar, where the purpose of sonar is to update that surface so that the operator is running with the most up to date information he can have.
Sure.
And sonars can be single beam. I mean, these surfaces aren't complicated. It's just some undulating surface, and based on point density is how well the sonar soundings represent the true surface. A lot of times it's not all that critical. So quick run with a single beam sonar, and he's got an updated surface, and we send that right back to the guidance system, our TMC, Thermal Marine Construction Software, and he's up and going. If he needs if it is more critical as to exactly what's that surface look like,
Yeah.
then you need to increase that point density, and then it becomes a multi-beam type function.
So we would get that using a USV. You go out there with the USV and drive that in a pattern that would get us the surface.
We can do it with small USVs. They can be programmed to run these lines, automatically, just like mowing the grass. It can be done in just a John boat and the work boat, the pusher boats.
And when a guy would call to get something like this, is this typically? I mean, depending on the size of the lake, obviously it takes more time. But reasonably for most applications, is it typically a day job?
It's a day job, and because face it, the dredge is not advancing and moving that fast, so we
Right.
just need to lay out the next couple months or something,
Right.
of production and movement, and then if it becomes a more critical time expedient need for cave-ins and things like that,
Right.
Multi-beam can be mounted directly on the dredge itself.
The dredge itself, yeah.
And again, we've got units that can mechanically pan and or tilt the sonar, so that it can look where you need it to look and give you the answer right then. Because it's a good thing for us. We can interface that directly to our software.
Right.
And the previous podcast I said I think we had 3 different softwares slinging data around inside on
Right.
a system that was placing stone from a moon pool barge on a river in Idaho. But
Right.
we do it now with one software, and with the push of a button, give it the time to scan. The operator's got an up to date surface. He's not waiting on a surveyor to come. He's not waiting on any of that. He's got it, and he knows.
So, what I think the detail that most ag mines miss is the idea of the fluctuation of the water level. And I was just thinking about it in my head. You have a wet year, when for a period of that time the water levels in the pit, let's say, is up 10 or 12 feet, could be more. Um, you're out there dredging, and now all of a sudden you're not near as deep as you once were, but yet you're still stepping forward, and so that could be a considerable amount that you leave.
Yeah, I'd made a statement that we've yet to gone to a customer that got where they wanted to be, or really knows what they had done over time. And it is over a lot of time, right? Because these ag mines are there for a long time, operating in the same place. But I could also say that if we looked at it, all those issues have to have stemmed from the fact that they're working purely from water surface elevation.
Almost mechanical gauges, right? A lot of them are just mechanical. For how often would you recommend? Well, let me go back up for a second. As far as cost effectiveness, right? Dollar for dollar, perhaps coming in and getting the surface using a USV or using a workboat or using whatever as a baseline, and then implementing the guidance system. That's kind of the idea of the baseline, most cost effective way to be at least somewhat close on that surface. Would you agree with that?
That's correct. So our typical install, we ask for somebody to have provided a survey of the bottom, right? So we've got a hydrographic survey that gives us the 3D point cloud rendition of existing conditions. We load that into the system, and then ever after that, as the cutter head goes through that surface, it removes it from the model that we're incorporating into our software.
Mm-hmm.
And as I'd said, if the operator's paying attention to that, as he should, and we've got color coding going on, letting him know, there's lots of tools there for him to use so that he doesn't miss anything. Then the next time the survey is done, there shouldn't be any surprises. And how often is that survey done? I mean, I don't know. We've worked in everything from rock and sand mines to copper and gold mines. So it's definitely a function of how much is a cubic yard of your material worth.
Right. And so, like a regular problem, I thinking about it myself. A regular ag might want to have it done once a year, something like that for most places. That'd probably catch 90% of the guys out there. Some of the guys might stretch it to 2, depending on how much they're stepping forward, realistically. But probably about once a year, just so you're on track. And if you've been training new operators, been doing different things, you don't have any surprises left behind. You don't get too far ahead of yourself.
Yeah, and the whole thing comes together. I mean, it's it's paraphrasing Lord Kelvin. I mean, first you measure, then you know, right?
Right.
So when we get that first surface, we can keep up with it, right?
Right.
And then when we give the operator the tools to know where he's at and where he's been, and update that surface as he goes, it's human nature. And I was taught by a crusty old naval officer that you get what you inspect, not what you expect.
Right.
So when it's human nature. So when Big Brother knows that he's on place and he can monitor what's going on.
Sure.
Well, things improve.
And then for that maybe 10% out there that have an issue where, let's say, they've got a lot of excessively large oversize, or they've got a real tall bank, that they really want to maybe even look forward a little bit to see what's happening in front of the cutter head. In those instances, then perhaps a multi-beam or a pan tilt would be a solution for them.
Yeah, the multi-beam sonar, and in conjunction with a pan and or tilt, we can actually tilt now electronically.
Yeah.
One of the things that's improved since we got started on the sonars on the barges. That's the way to go. The issue is probably still the price point.
Right.
But we do have some things in the works. We're on some projects where we're doing some things internally, driving down that price point.
Right.
And even that usability that I referenced last time I was here.
Right.
The user interface, we're we're taking taking away a lot of the buttons and the functions that the dredge operator doesn't need.
You make it intuitive.
We're making it intuitive. We're streamlining it,
Right.
and making it more user friendly.
Because I think some of the feedback we've got from other people's competing devices, I should say, is that they leave a lot there. It's difficult for the operator to navigate. Easy to accidentally push something that puts you in a spot where you're unable to kind of navigate back to where you want to be.
It can be, and when the system has to be installed, and I've said it before, quite a few measurements, all the sensors tied in together, dialed in, and driving the error budget down to as minimal as we can get it. And that's what our guys take care of, right? So, but once that's done, on a barge, be it a construction barge or a dredge, once that's done on that project, it doesn't need to be changed.
Right.
So our guys take care of that up front in a couple days' time, and then it just runs.
And then training after that. So the company where let's say if you're going to do a complete sonar package, right? We're gonna do the positioning and sonar. What to expect for training on that?
Yeah. So really, if a mining organization goes to that extent that they have this type of equipment on board, they really need a champion, what we call, on site, and that's a person that's not afraid of computers and can understand software, and they work with our techs during the install, and here's all what's important, here's the measurements that matter, and
Right.
we can't have any changes in these, and we bring them up to speed, and they're and they start doing the data crunching and analysis and stuff, so they become integral to that whole operation. So the when the investment's made to that level,
Yeah.
a piece of that investment has to be that champion.
Right.
So because technology, it still doesn't run itself.
So even with the package and the training, which would probably be a few days in the field, I would imagine, right? Then after that, they have phone support for Measutronics for a period of time, and that's in that phone support, you can actually log into the system and walk them through problems if they should have it.
Yeah, that's correct. And it is typically a few days of training. I'm training with the operator as well, because he needs to understand all the
Right.
tools he's got in that software and all the functionality that we can offer him. But then, as far as support, we do have cellular connectivity. If we can get on board through the internet, then we can service and support remotely.
Right.
Some places are isolated, so it's going more to the satellite
Yeah.
connections,
That kind of stuff. Yeah.
that kind of stuff. But that stuff's solid now, and it's coming down in price as
Sure.
well.
Yeah.
So support is typically not too big an issue for us. And
Right.
again, when our guys put the gear in at the front end, I always make the point, hey, this has to be solid, because the better the install is at the front end, the better the performance, and we're using top of the line sensors,
Yeah.
field tested and hardened, and they just typically don't fail.
Right.
So once it's in there, the support burden, at the front end, we do a couple weeks where we check in with the operators, and a lot of them, it'll be the first time they've used a system like this.
Sure. Right.
Say, hey, how is it? And well, I like it, but I never used this number here, and I'd like this one bigger,
Right.
because I look at that all the time.
So it's all customizable.
It's all customizable,
Right.
and it just takes us a while to get some feedback from the operator, and we can even make it, shift to shift. We can make it so that with a drop down menu, you can
Switch between one operator to the other.
have it
Yeah.
customized per operator. Yeah.
Very good. Well, it's amazing how technology has advanced in that aspect, for sure.
It has, and then we're pushing it further. We got some things coming. That we've got all these means of collecting all this data now, and now we're looking at what we can do with the metadata. So data about the data, right?
Right.
And really making that accessible to the more so at the owner and the manager level.
Right.
So we can find those sweet spots of the material. We can map them out. We can track that. We can improve on their models that they get from core borings and
Right.
such.
Literally, it's kind of the thing right now. If you have a question about what can be done, ask, because there's very little limits on what's out there. I mean, it's just if you want a map of this or that or the other, or you want to be able to look at the surface in terms of where the good material is based on corings and have that laid out for the operator to seek that material out, you can set all that up.
It can be, and traditionally it hasn't been. So we're just scratching the surface.
Lou, thanks again for sitting in on scratching the surface here.
You're welcome.
I'm sure we're going to do some more of these. I appreciate you coming out again.
All right, you're welcome. Thank you.
You're welcome. All right.
How about that?
So we talk about
Cokes.
your dented can.
Yeah.
Cracks me up, man. That's a great.
And see,
It works. It works.
It's a habit. I
Yep.
can't. You know that story, Nathan? Coke cans like this. See how I dent it? I always do. No,
There's a reason.
there's a reason for everything I do. But on the destroyer, we stand and watch. It's totally black, right? And the guy that was my conning officer, he dipped snuff, and he'd be spitting in the can. And there was like a dashboard thing up here at the front, and I picked up a can. I took a big slurp, and it was his spit can.
Oh God.
And I went like that. And next morning, when the sun comes up, Skipper was walking out on the bridge. He says, "What the fuck is it? Who made this mess?" Because I spewed that stuff all over the place. And they said, "Oh, it's Lieutenant Nash." It's Lieutenant Nash Bridge. But yeah, so ever after that, and I never told anybody because I didn't want them fucking with me. But
Right.
if I didn't feel that dent, I didn't drink from that can. And I still do it, but it works at parties, and it's a
I'm
weird.
gonna start
habit,
denting
isn't
my
it?
can, but I can't. If Lou comes to town, he'll think that my can's his can. I gotta come up with something else.
It's dark, you know?
Yeah.
Man, it was warm and
Oh,
slippery.
oh God.
It was
Everything you would imagine it would be.
it was bad.
Yeah.